This is a video recording for page 290, practice now 12. So the question tells us that sine theta is equals to A, and it tells us that A is an acute angle, meaning that, theta is an acute angle. So that tells us that theta is in the first quadrant. So theta is acute, meaning theta in first quadrant. So we sketch out the triangle. It looks like this. Theta, sine opposite over hypotenuse. So since opposite over hypotenuse is equals to A, we can therefore write opposite value, the length, the height is A, and the hypotenuse is 1. Therefore our adjacent side will be 1 minus A squared. For part 1, sine of 2 theta is given by 2 sine theta cosine theta. That's the expansion. So 2 sine theta is already given to be A, and from the triangle, cosine theta will be our adjacent, 1 minus A squared, over our hypotenuse, which is 1. And this results in 2A square root 1 minus A squared. For part 2, cosine of 4 theta is given by 2 sine. We have 3 options to choose from. So you can consider this is cosine square 2 theta minus sine square 2 theta, or 2 cosine square 2 theta minus 1, or 1 minus 2 sine square 2 theta. So we need to decide which is the easiest formula to use to solve, to rewrite cosine 4 theta. Let's take a look at each of them. If I were to consider using this, cosine square 2 theta minus sine square 2 theta, I will therefore need to find cosine 2 theta first, an expression for cosine 2 theta in terms of A, which I don't have at the moment. I will also need sine square 2 theta, meaning I need sine 2 theta, which is found in part 1. Okay, so first option will result in some difficulty. I will need to find cosine square 2 theta first. Let's consider the second option. Similarly, I still need cosine square 2 theta. And the third option, I only require sine square 2 theta, which is simply the square of sine 2 theta. And that is what I will be using. Since part 1, we already have the expression for sine 2 theta. Let's replace all of them with 1 minus sine square 2 theta. 1 minus 2 sine square 2 theta. And this will result in 1 minus 2. Whatever is in our sine 2 theta, we're going to square it. So we're going to put this here. 2A square root 1 minus A square. Expand it out, 1 minus 2 times off. So 2A we square, we get 4A square. And inside the bracket, inside the square root, 1 minus A square. Since we are going to square a square root, it disappears. And leaving us finally with 1 minus 8A square, negative 8A square, times a negative A square, we get positive 8A power 4. And for the last part, cosine square half theta. How are we going to obtain cosine square half theta? Oh, we remember that for our double angle formula, we've got cosine 2A equals to all sorts of answers. We've got cosine square A minus sine square A. We also have 2 cosine square A minus 1, as well as 1 minus 2 sine square A. A is simply a constant. Now in this question, it is not as straightforward. They want cosine square half theta. Out of all these options, we see something similar, a cosine square of an angle. It is found here and here. As long as I can replace the angle A with half theta, I'll be able to make my job easier. The question is again, should I use option number 1, where it includes sine square A, or should I choose option number 2, where it is just cosine square of an angle minus 1. Then the answer should be clear to you is that we will use option number 2. This is the one that we're going to use because I don't have to do with a sine square of an angle. We can rewrite all these if I want cosine square half theta, meaning I want to replace the a over here with half theta. So all my a's will become half theta. In other words, I have rewritten cosine theta to become 2 cosine square half theta minus 1. From here, we can make cosine square half theta the subject. But before we carry on, if I want to make cosine square half theta the subject, it will be in terms of cosine theta. Am I able to get cosine theta from the triangle? Yes, we obtained it earlier on already. Cosine theta is simply adjacent over hypotenuse, square root 1 minus a squared divided by 1. So we know that we are able to proceed. So let's continue. 2 cosine square half theta is equal to cosine theta plus 1. And cosine square half theta, which is what the question wants, is cosine theta plus 1 divided by 2, which we found was square root of 1 minus a squared is divided by 1, but we won't be writing that, and all this over 2. So this is the answer for part 3. Now moving on to practice now 13. Question 1. We have to solve 2 sine 2x minus 3 cosine x is equal to 0. So we see that there is something that we can do over here, sine of 2x. We can rewrite it to become 2 sine x cosine x minus 3 cosine x equals to 0. Expand it out, we get 4 sine x cosine x minus 3 cosine x equals to 0. Here we can find a common factor, cosine x, so we're left with 4 sine x minus 3 equals to 0. I have the equation in the form of a times b equals to 0, which means that a either equals to 0 or b equals to 0. So we have two answers, two options, cosine x equals to 0 or, skip some steps, sine x equals to 3 over 4. Now when we have cosine x is equal to 0, draw a graph to help us visualize from the angle of 0 to 360 degrees. When it's 0, we've got x equals to 0. This is 90 degrees, 180, 270 degrees. So x will be 90 or 270 degrees. Then over here we have other options. Let sine alpha be equals to 3 over 4. So to find the basic angle, inverse sine of 3 over 4, 0.848. So we see that x is in quadrant 1 and 2. So we have x equals to 0. No, it's not 848 since it is in degree. So inverse sine, we get 48.590 degrees. So the first answer will be 48.59 degrees, and the second 180 degrees minus that basic angle. Round them off for the 8.6 degrees. For answers in degrees, we will leave them in one decimal place. And we finally combine all our answers. So x will be, and arrange them in ascending order. Okay, now for the second part B, again we need to solve. We want to find the value of x. The only thing that we can do over here is to rewrite our cosine 2x. So let's put it at the side. Cosine of 2a is equals to cosine square a first, minus sine square a, which is 2 cosine square a minus 1 minus 2 sine square a. So all these, they are equivalent. The question is, what should we choose? We see that the equation also has a sine x. There's a constant also. So if I were to use option number 1, I will get a cosine square and a sine square. The cosine square does nothing to help me. It only complicates things further. The sine square is fine, because with a sine square and a sine over here and a constant, it becomes a quadratic equation. So let us consider option number 2 over here. If I rewrite my cosine 2x into cosine square x, I will have a cosine square x term plus a sine x, which again doesn't help. And finally, let's move on to the third option. If I rewrite cosine 2x in terms of sine square a, then mentally I can foresee that it becomes a quadratic. And that is the option I'll be using. So let us rewrite it now. 2 cosine 2x, 2 times of cosine 2x becomes 1 minus 2 sine square x plus 3 sine x minus 2 equals to 0. You should eventually be able to make the decision mentally without needing to write all this down. So we expand this out, we get 2 minus 4 sine square x plus 3 sine x minus 2 equals to 0. So this is now a quadratic equation. We typically like to leave the coefficient of the sine square x as positive. So we can rewrite this to become 4 sine square x minus 3 sine x. So 2 minus 2 is 0, equals to 0. The three methods, completing the square, quadratic formula, factorization, and of course graph method, they all still work. So it is your decision now to decide what is the best method. I feel that sine x can be factorized out, so we get 4 sine x minus 3 equals to 0. So here we again have two options, sine of x equals to 0 or sine x equals to 3 over 4. So I see that this is positive, so x in quadrant 1 and quadrant 2. Now let's tackle the first one. So since sine x is equal to 0, it's quite clear that we are looking for angles x to be 0, 180 and 360 degrees. And on this side, let sine alpha be 3 over 4. So again, we get our basic angle alpha, which seems really familiar. Sine alpha is 3 over 4. It's the same. Okay, so alpha is 48.590. 48.590 degrees. So here we have x to be 48.59 again, or 180 minus 48.59. And our values were 131.4. Okay, so this is rounded off already. So combine all your answers together. We have x to be 0, 48.6, 131.4, 180, and 360 degrees. Okay, now I shall not write down the three options for our expansion of cosine 2x already, because we need to practice doing them mentally. Option 1 is useless. because I will end up with a sine square. Option number 2, I can rewrite my cosine 2x to become 2 cosine square x minus 1, then minus 5 cosine x equals to 0. In this way, I obtain a quadratic equation where we have 6 cosine square x minus 5 cosine x minus 3 equals to 0. Then the option to factorize is there. But in this case, this cannot be factorized, so we will need to use our quadratic formula, which tells us that if you like, you can rewrite this to become 6y squared minus 5y minus 3 equals to 0. Okay, this is much easier. But I think you can also do it without replacing cosine square x with y. So straight away write down the answer. Cosine x will be minus b, so negative 5, plus minus square root of b squared, so negative 5 we square it, minus 4 times of a, which is 6, times negative 3, which is our c value. All this is divided by 4 times 6. So we have 5 plus minus square root of, evaluate everything out. Okay, this should have been a 2 over here. And this is 12. 2 and 12. So now I have 2 different values for cosine x. So when we evaluate this, we get 1.237 or negative 0.4040. And we need to consider, are both of them to be accepted? After I say this, some of you probably will think that we should reject the negative, but do you have a reason to do so? In fact, this is the one we should be rejecting, because cosine of x cannot be more than 1. Okay, so now we have half the work left to do. Cosine of x is negative 0.4040. This tells me that x in quadrant 2 and quadrant 3. So let cosine alpha be 0.4040. We find that alpha is, this time the question is in radian mode. So we get basic angle of 1.1549. Based on this, we know that x will be in the second quadrant, pi minus 1.1549, and then in the third quadrant, pi plus 1.1549. Of course, we can keep going on and on, but take note that the range of values for x is from 0 to 2 pi only. So these will be our 2 answers. So round them off and we get 1.99 or 4.30. And the last one for practice now 13. We have tangent 2x on one side and tangent x on the other side. This is a double angle. So I am going to rewrite this to become 2 tangent x over 1 minus tangent square x equals to 3 tangent x. Now it looks like it got more complex, but by doing so, I only have tangent x. There is only one type of angle, which is x. Let's get rid of this fraction. Okay, I'm going to multiply the left and right side by 1 minus tangent square x. And let's see what we can do from there. So 2 tangent x is 3 tangent x multiplied by 1 minus tangent square x. And we can factorize because there is a tangent x. Okay, let's move everything to one side first. 2 tangent x minus 3 tangent x, 1 minus tangent square x, and this is equal to 0. Now you can see clearly that there is a common factor which we can factorize out. So tangent x, Okay, 1, sorry, not 1, this is 2. 2 minus 3 times of 1 minus tangent square x equals to 0. Tangent x, 2 minus 3 plus 3 tangent square x, 0. And now it becomes a case of a times b equals to 0 again. So we have two options. Tangent x is equal to 0, or tangent square x is 1 over 3. From here, when it is angles, when we have a tangent, sine or cosine of an angle equal to 0, I like to use the graphs to help me, because you can see that these are the three values. X will be equal to 0, 180 and 360, but since it is in radian, we have 0, pi and 2 pi. So this is a practice for us to sketch our graphs also. Now tangent square x is 1/3, so tangent x is, because now we are introducing the square root ourselves, we have two options. What this means is that x is now found in quadrants 1, 2, 3 and 4. So same thing, get the basic angle out. Let tangent alpha be 1 over 3. Alpha is actually pi over 6, our 30 degrees. Okay, tangent of 30 degrees, we get square root 1 over 3. So now x must be pi over 6 in the first quadrant. In the second quadrant, it will be pi minus pi over 6. In the third quadrant, pi plus pi over 6. And in the last quadrant, 2 pi minus pi over 6. Combine all the answers together. We have x equals to 0, 6, and 5 pi over 6, pi, and 2 pi. So all these are the answers.